So I'm going to go over the phosphorus cycle since I'm not going to be in class today, so you can get an idea of what you have to know on the test. Well, the test is still scheduled for Thursday. The phosphorus cycle mainly cycles as phosphate. That's PO4 negative. You have to know both the compound and the name of the compound. It's unique to the other cycles because it only circulates through the hydrosphere, lithosphere, and living things. It does never enters the atmosphere. So if you look at this picture, it's, even though you see weathering kind of starts it, phosphate or any part of phosphorus never hits this area over here. So how does it start? Or what starting point are we going to start with? Phosphorus is released through the breakdown of rock. And the breakdown of rock occurs through weathering. So you're going to have some kind of wind, rain, or something that's going to break up rock. And a lot of the phosphate on Earth is found in rocks. So make a note of that. Then it can either be dissolved into water, and so that if you're looking at the diagram, it would go from here into this area over here. Or it can be taken in by plants. So it goes underground into the soil and the plant takes it in. Obviously, once the plant has it, a food chain begins. Same thing can happen in the water. If it's dissolved by the water, a plant in the water can take it in and the food chain start. So here they're showing you phytoplankton, which is our biggest producer on Earth because it's found in the oceans. And then once the food chain is over, just like every other cycle, there'll be decay or waste. Decay being organism dies, or waste from the organism will be returned to the cycle, to the litho, the hydro, not the atmosphere, by decomposers. I also want you to know that phosphorus is excellent fertilizer. All right, sulfur cycle. So like the phosphorus cycle, sulfur is mainly found in the lithosphere, a lot in the soil. It's like phosphorus, it's a good fertilizer. Let's start with how it gets into the atmosphere. Volcanic eruptions, fossil fuel burning, or any kind of organic burning is going to put sulfate right here, SO4 negative, or sulfur dioxides into the atmosphere. That's mainly how this sulfur is cycled in these two compounds. Once it's in the atmosphere, so I'm right here, it's going to react with water, so H2O, and it's going to form sulfuric acid, which is right here, which is H2SO4 negative. Sulfuric acid is going to come down from the atmosphere, and it's going to either land in the lithosphere or the hydrosphere. This is what you reference as acid rain or acid deposition. Once in the lithosphere, plants can take it in. Same thing can happen in the hydrosphere. There could be an aquatic plant, takes in the sulfur. It's going to convert the sulfur into amino acids, which are organic compounds of sulfur. And like in every other cycle, the food chain will begin. So some organism is going to eat the plants. In this picture, they're referencing a deer. And the organism can either die, the plant can die, or waste can be produced. And then the decomposers will take the sulfur and return it back into all the layers of Earth. Now there is a compound here, which is hydrogen sulfide, which is also kind of a reduced form of sulfur, and it's part of the sulfur cycle. So just a refresher, if you're asked the question, where is phosphorus and sulfur cycle mainly found, or phosphorus and sulfur I should say, they're mainly found in the lithosphere. Nitrogen cycle in the atmosphere, you know it's 70% of the atmosphere. In the hydrosphere, obviously you have the water cycle, which makes up the hydrosphere, and the carbon cycle trapped in shells as calcium carbonate. Just some extra things, as I mentioned in the previous slide, sulfur and phosphorus are good fertilizers, and so is nitrogen. These are going to be discussed further in the upcoming chapters.